Welcome to this new tutorial on Emgu CV. In this tutorial, I will show you how can we apply template matching in Emgu CV. So let us get started. I already created a project and configured to use Emgu CV 4.2. You can check one of my previous tutorials to see how I configured this project. So first let me add one new menu item here and I call it template matching, and I just want to see apply matching here. So when I click on this matching, I will be able to perform a template matching. So in order to perform template matching, we need basically two images. One will be the template and one will be the original image. So we need to select the template and we need to search that template one by one inside the image. So one thing that I will do is I will use this select region of interest. I showed it in Emgu CV 3.4 tutorial, and this will be used to select a template. What I want to do is select a small template from the image itself and try to search within that image. So let's assume that we select the region of interest by using this menu, and when we click on matching, we will be able to apply the template matching. So the first thing that I want to do is to apply the try catch block, so that if in case of any error, my program will not be crashed. So in my previous tutorial, I defined few variables, and one of them was this rectangle for a region of interest. So I assume that the user has already selected the region of interest before coming into this new method. So I will apply two conditions to make sure I have an image. First thing is I have an image in my picture box so that I can do processing on it. If it is equal to null, it means there is no any image that has been already displayed. Then we should do null. And also in the same, if I will also check if my rectangle, that is region of interest, is also null, then I'm just going to return. So I will do nothing. So it means that I should have selected a template to match in my original image, and I have some image in my picture box. So once I have the image and I have selected the rectangle or a template from within that image, I am just going to search that image, that template within the image. So but in a real application, your template may be from outside. You will be selecting, it will be in another image, you can read it. But for simplicity, I'm just going to show you, assuming that I will be using this template from within the image. So one thing that I want to do is which is my scene image, that is the original image where I will be searching for my template. I just call it img scene image is equal to, and this I believe that it is already in my database. That is, the user has already selected an image and put it in this img list, which is basically a dictionary I already created to storing different types of images and their results. So once we have the image, and I just call it is the input image in my image list, and I just want to clone it. Why I am cloning it is whatever I will make the changes into my image, I don't want those images to be replicated into this image database dictionary, because if we copy it, it is just like copying a reference. So when I have the reference, if I make any change, the original data will be changed. So when I clone it, it means that I'm making a complete copy of that image, so the original will not be changed. That's what my objective is. And now the template let's create a new bitmap image, and the template will be selected by the user, and I will display the template in my picture box. So dot image, so we will select the template and put it in our picture box. from the original image. So I'm reading, so this is the template and this is the image where I'm going to search for this template. And since this is going to be an image, I need some features of the image, not a bitmap, so I will convert it into an Emgu CV data structure, and I assume that this is a BGR image, and depth is also bytes. So that's it. So once I have the template and the scene, now I can use the method in Emgu CV, which is called the match template. But the match template is expecting some output image, so I'm just creating an output mate object. So I call it img out is equal to new img out, and this is where I just want to store the results after my matching has been performed. So let me call this method cv.match template, and this match template is expecting an input image. This is the image where I'm going to search for the template. So this will be the first, will be the scene image where I'm going to make the search, and the second parameter is the template which we are going to search within the image. So one by one we are scanning the whole image for the template. And the third argument is, you can see the result or the output image. So I just created this img out. So whatever the results it will get, it will put those results into this img out. And the next, what was the next argument? So which type of matching methods that you want to use, and there are quite a few types of matching that we have. And in this matching we have cross correlation coefficient, we have cross correlation and a correlation coefficient. Those are normalized correlation coefficient. Squared differences are normalized, squared differences, normed squared differences. Remember that whichever method you select, it depends on whatever you want. But there is one thing that you should remember, that when we use the squared difference, so it is actually finding the difference between every pixel in the template and every pixel in the image. And if you want to find the best match, then in that case, sum of square differences or square differences normed, in that case we need to find the minimum difference, so that we believe that the similarity is maximum. But if you select, for example, the correlation coefficient or normalized correlation coefficient or cross correlation, in these four types of methods, you will be looking for the maximum match or the maximum value in order to find the maximum match. So right now, just for the sake of example, I'm just using this sum of square differences. So I'm just selecting the square differences. So what this template is actually doing, it is putting the template on every location in the image scene, and it scans it in row wise, and it then goes to next row, and so on and so forth. So essentially this image will be another image where it will give us the values in every pixel, whatever the methods we have selected. So these values will be, for example, the sum of square differences will be there in the img output at every location. So from that location we will try to find out the minimum value in this sum of square differences. So how can we find the minimum value to find out the best match? Is, let me define some of the variables for the minimum value and for the maximum value. So we need a double, call it minimum val, is equal to, let's say, 0. I assume that it is initialized to 0. Double maximum value, what is the maximum value that we have? And this is basically, I will use the minimax method to find the maximum and minimum value, and this minimax method requires these parameters, so I am forcefully writing. I don't need all of these, but I have to define them. And the point minimum location is equal to a new point. I will create a new point for finding the minimum location of the minimum point, and one for the maximum location, so I'm just calling it the maximum location. And now I'm from this template, once I get the matching and the square differences values, and now I am interested in finding the point, what is the minimum value and what is the location of that minimum value in the template, so that I can draw that template on my image. So I'm using cv invoke dot, there is a method minimax location. So this one will give me minimum and the maximum values as well as locations where we find those minimum values or maximum values in this image. So minimax log, the first parameter it is expecting is the input array where I am going to search for. Definitely it is the img out where I am going to search for the locations. The second is we need to provide a reference variable for maximum value, as you can see, so that I have already created, I will use this keyword ref in order to give it a reference value so that its value will be directly changed. So this is the minimum value. It will give me the minimum value, and this one will give me the maximum value within the template. What was that value? And for this minimum value, what was the location? So I, for the minimum, what was the value of the minimum and what was the location of the maximum values? Okay, so that is it. Max location. So this method is trying to find out what is the minimum value and what was the location, so at which xy coordinate, and this is the maximum value and what were the locations. So I will use these minimum and max locations to find out, to draw a rectangle around the mesh. Once I have the locations, I can just create a rectangle. So I just call it rectangle. R is equal to new rectangle, and here I am going to provide the starting point. For example, it's like this. We can give a starting point. So as I mentioned, that don't forget, if you are using square differences, then we will be using the minimum location. If we are using any other method like correlation coefficient or cross correlation, then in that case we need the maximum location. So here I am selecting the minimum location. So I am going to draw a rectangle at that minimum location. So this is the left top corner of the rectangle, and for its width and size, I already know the size of my template, so I can say draw a rectangle same as the size of my template, starting at this location, minimum match location. Okay, once I have the rectangle, I can draw this rectangle on my scene image. This is the scene image. So cv invoke dot rectangle. So we can use the rectangle method to draw a rectangle on the scene image. And next it is expecting a rectangle. So we have already created a rectangle R, and you can select any color. So for the color, I am just providing BGR, means blue. It will be a blue rectangle, so rest of them are 0, 0. And if you want, you can provide a thickness. Otherwise, it will use a thickness of 3, just to make sure that I can see that I am putting the thickness to be 3. And now we can draw the image on our image picture box. So img scene dot is bitmap. Okay, so here what we did is we selected the scene image or the original image, and we select the template. So I will show you how we select the template, and then this one will go through all the row wise and column wise to scan whole the image, and it will give us locations where it will find the sum of square differences. In this case, I have used sum of square differences, and now from those locations we want to find out the minimum location of the minimum match, which means that we have the if the differences are minimum, it means that the matching is maximum. So we use the minimax method to search the IMG output, and we are interested in finding. Although this method requires all these parameters, that's why I need to define them here, but I am right now interested in the minimum location. So using that minimum location, I just created a rectangle at that location, using that location and the size of the template, so that I just draw it, that rectangle on my original scene, and I just want to show it. So let us run and see the results. So let me select an image. So file, open, and let me select this image, and now I'm going to select an ROI, so that I selected this logo, for example, and then crop that area. So get region of interest. I developed these methods in previous video. So this is the template that I'm going to search inside my original image. So I selected the template because in my code I have written that this one should be selected. So this is the picture, current picture template, and I'm going to click on matching. So you can see that the template matching was able to find out the exact location of my logo or the selected template, for example. Let me select another image, and this time, instead of selecting that one, I'm just going to select another template, for example. So here I'm just going to select another ROI, and let's say I'm interested in this template of the flags, and I'm doing get region. So I'm looking for this region or this area, this template. So what it will do, it will start searching for this template in the image, and it will scan whole the image. And where we have the minimum sum of square differences, we believe that this is the location we will have the minimum sum of square differences, and it will find it. So let me select that template, and I'm just going to apply the matching, and now you can see that it find the exact location. And similarly, if I do the select any other method, for example, if I do the correlation, normed correlation, for example, and in that case, as I mentioned, I am interested in the maximum correlation to find the best match. So I will be using max location here, and let me test it again. And in this case, let us see, open the file, and let me select the same images, or let's say this one, and I'm going to select a region of interest, and this is the region of interest that I'm going to search for, and let me say the template matching. So you can see that it is able to find out the location. So what the main problem is, I'm just selecting the same image from the template within the image, and I am searching it. And as you can see that the size of the image and the place where I'm looking for the template are of the same size. Now I will show you the main problem with the template matching, where if the scale of the template changes, or it is somewhere rotating, then it is difficult for the template matching to find it. So to do that, I need to add some more features into my program. So let me say I want to find out utility. I'm just writing a utility, and inside that I want to do transformations, and I want to do, for example, resize. I will resize the template, and I will also do, for example, rotation here. So I just want to test with the resize of the template, and I will do the rotations and then apply the template and see what happens. So double click on the resize. The first thing that I want to do is to write this try catch. Okay, so message box ex.message, And the second thing that I just want to make sure, when I click on this get region of interest, I put that template into my dictionary using this name. So I will be using this name to make sure that I have already selected an image in my database or not. By database, it means I'm in my image dictionary. So the first thing that I'm going to do here is if not, so img list and dot contains key, and if it not contains this key, then we are going to say that please select a template and return. Okay, so we assume that they have selected the template, and now we are going to resize that template. So let me read the image first from my picture box. So this is how I'm going to do is bitmap. I'm going to create a bitmap object in picture box dot image and dot to image, so that I just need a bgr and a byte. Okay, so here is the bg, should be capital. Okay, so now I read the image, the template from the picture box, and now I want to resize it. Let's say img is equal to img dot resize. I will use the resize method. And what should be the scale? For example, I just want to increment it by 0.25. So every time I click it, its size will be increased by about this 25%. And what type of interpolation that I want to use is interpolation type dot. You can use any one, but the cubic will give better results for me, for example. And once we resize the picture, I just want to do show in the image again. So is equal to img dot is bitmap or to bitmap, doesn't matter. And also I just want to add this into my dictionary, and this is the image, and the key name that I just want to use is template resized, so that I will resize the image and again perform the searching. And I also want to do the rotation of the template and apply the template matching if it can find it or not. So I am just using this same code, copy it and paste it here. And the only thing that I will make a change, not only thing, two things. The first thing is, instead of resize, I will be using the rotate method to make a rotation. And let's say I want to make a rotation of 90 degrees. And for the rotation, what will be the background? Because if we do a rotation, some part of the area might be empty. So in that place, I just want to make it dark. And the last parameter that it is asking for, if you want to crop the image to bring it to its original size or not for the template. So I'm saying no, I just keep it whatever the size it has. And this second thing that I want to make change is I want to add this rotated image also into my dictionary, and I just call it image rotated, and that's it. So let us run and see whether it is doing correct resize and rotation or not. So once again, let me select an image, let's say this image, and I want to select an ROI. So this is the ROI that I have selected, and get the region of interest. So this is the, now I want to make a rotation or resize of this image. So in the utility, in the transformations, if I do resize, for example, so you can see that it has been resized. This is the ROI original image, and this is the template. You can do as many time resize because it is doing on the current image in the picture box. and also you can do rotations, for example. So you can see it is rotating, so it will again rotate it. So as many times as you want, it will be doing 90 degrees rotation. So now I'm interested in applying, for example, this is, I do a resize of my template, and let us see if it can do template matching or not correctly. So now you see that the original image or the template, which was somewhere here, has now oh, I forgot to show the results for my template. So let me once again do the matching. So the problems also with the template matching is obvious here. It is expecting most of the time to give us good accuracy. The template should be almost the same size as whatever we are trying to search in the original image. But in real examples, we might not have that possibility, that the template that we are searching may not be the same size, or even it will be rotated somewhere. So, and if I do, for example, even if I do a rotation here, and let's say if I do rotate it, and now I'm going to search this rotated template again in my matching, I'm not so hopeful. So let's see that you can imagine it thinks that the match, this is the best match, although it isn't. So in my personal experience and a suggestion is that if you are sure that you are doing a simple matching, then in that case, and you are sure that the template and the place or the image where I am going to search will be same, and just I need to do a very simple and a quick matching, then template matching is there for you. But if you are not sure what will be the size, or what will be the rotation, or what will be the transformations on my template, then in that case template matching will not give you the expected results. So in next video I will show you a little improvement of how can we do a multi-size template matching by introducing some, you can say, multi-scaling template matching. And then next we will look for a very robust feature matching based approach for finding the templates in an image. I hope you enjoyed the video, and hope to see you in the next video.